Hello everyone, welcome to AI Anytime channel. In this video, we are going to look at Weave by Weights and Biases. So if you don't know about Weights and Biases or WANDB, a very famous tool to basically look at the logs and ops part of AI and machine learning ecosystem. So when we call it AI ops, ML ops, and nowadays a hyped word called LLM ops. You know, you can use weights and biases WANDB to basically look at whatever is happening underneath of your LLM or Gen AI based applications. So weights and biases provides a service called Weave, and that's what we're going to look at in this video. So most of the time, you will be working with multiple large language models when you are working for a client, right? When you're working with a RAG solutions or a RAG chatbot or a conversational AI, a chatbot kind of a thing, you might, you might be changing the LLMs when you are baselining that which LLM is suitable for your data and your use case. In that context, you need these kind of tools where you can, automatically benchmark your RAG chatbot underneath. That's what we want to look at in this video. So I'm not gonna like write any code. The code is already available. I'm just gonna walk you through how you can do that. So if you look at here on my screen, we're gonna use Weave and OpenAI. You can use any other model you want, but I'm gonna show that how you can use uh, Weave to basically evaluate and baseline a chatbot. So Weave provides a feature called accuracy verification. So we're going to look at the accuracy verification procedure when changing the LLM, while working with a RAG system, and that through Weave. So the first thing that we're going to do is we're going to import Weave, and you're going to ask for, uh, you can give it a name. So for example, I'm gonna rename it to. I'm not gonna initiate that Hello Weave. Let's say RAG baselining, and you can see it says logged in as weights and biases user and view wave data at this link. And you can open this link. It will take you to weights and biases dashboard. Now here you can find no traces. Ops are an important part of your RAG chatbot, guys. You should know because LLMs have tendency for hallucinations and biases and so on and so forth. You need a system which you can use to basically evaluate, right? And that's what we're gonna use this tool. You can use other tools like Langsmith, Agent Ops, and so on and so forth. Now you can see this is what it's showing. It says RAG baselining and traces and no traces yet. So let's go back here. Next, what I'm doing a pretty basic thing here. I have my OpenAI keys set up here in the environment in the left-hand side. You can see all of my keys here. So what I'm doing, I'm just, if I run this command, I'm just gonna, or maybe we can get rid of this now. I'm just gonna run this, and you can see I have my keys. Like now, I've set that up in the env, and I'm just importing it from there. Excuse me. Now we're going to use OpenAI library. You can use the same LangChain and Llama Index or any other orchestration framework. Just for the demo purpose, we have client equals OpenAI, initiating the OpenAI client, and then we have a pretty simple chat completions dot create module from OpenAI. I'm using GPT-4o mini, and I have a role where I'm passing it like please translate English into Hindi, and I'm saying AI is an old technology. So if you just do this, let me show you what happens when we run this. If you open this, it will show you the traces now. So if you come here, you can find out the traces over here. It might take a few seconds to show you, but you can see it over here. It says OpenAI.chat completions.create traces. This is right now loading, but here it will show, whatever you have, whatever operations you just did, right? If you have defined any name, it will also take that name. We're gonna see that in a bit, but yeah, this is what it is. Here you can find out your system, user, output, input, and output basically. Then you can find out your everything related to calls. You have your this pretty code that it uses the import weave and whatnot. If you have any feedback added to this call, you can also do that. The summary of it, you can see I'm running it on this system, Linux, because we are using Colab, so on and so forth, right? Perfect. Now this is a pretty simple thing. So not any fancy thing over here, but we're gonna go next. Now, what it does, you can use weave.op, you know, basically it's you can, you can initiate you can use this as a decorator, as a Python decorator that will record, the function basically, and the input and the output of the function. So that's what we are doing here. If you look at, we are doing weave.op, you know basically an operations kind of a thing. So we wave dot off, and then I'm writing a function. I just wrapped this code in a function. You can see it over here. It's pretty same code that we have, just only getting the user input from an input param over here in the function, and then we are just passing these input params here. Now if you run this thing here, now it will show you. So I'll show what I'm saying. Now you can see it has something called translation. So previously we just did, something which was not having a name to it. You can see the translation. Earlier it was like, if you look at here, right, there is no translation. This is an openai.chat.completions.create module that we use to do that. But now here you can find it out, your translation. So if you look at this translation, user input, and then the output, the same goes with code, the feedback. If you don't have a feedback, if you look at the code now, it basically captures the input and output and the function as well. So the function that we have used right over here, you can see that. Now the good thing is that you can find it out your basically it's create an hierarchy as well, from which question you like first ask the query input and the next one. So that's what it's going to do. So here we have the translation, and this is the previous one. Now if you go next, now, if you look at, I've also made a note. I'll give this notebook, of course, from my GitHub repository. You can also specify, weave.model as the class inheritance. So I'm going to show what I'm talking. So if you look at here, we have a class called translation model, and we are saying weave.model, and this remains the same. Okay, weave.op that we have just wrapped it here in a function. So if you come down and let me just run this, then you will understand what I'm saying. And let me open this. And now you can see translation model.translation, right? That's what you are seeing. Now, if you look at the translation model.translation, you can find it out. Basically, it's a very object-oriented based mechanism that we have been taking up here. You can see it gives you the self, the translation model value. You can have multiple functions within that class as well that you are defining. You can see translation model.translation. It gives you, again, it wraps up the code, but only the code that, not the class, by the way, the class that we have defined, but only the model part of the function of it. And you don't have a feedback, you have the summary and how you can use this later on. So this is what it is. Now let me uh, you can, if you go to, let me, so if you go to model now, you can see the model thing, that which model that we have been, you like the entire code. So earlier, if you go back for these things, okay, let me come here. Excuse me, this one. Go to traces, excuse me. You can find out all the ops that we have been doing, here, translation. But that time when you ran this model was not available. Now it's available because we have just used 1 minute ago, right? That's what it is. Now if you go back, this is how pretty simple you can record your LLM calls, or at Weave. Now the next thing that I'm going to do is build a simple RAG chatbot, a very simple RAG pipeline. So what we are doing is I created a document. You can see it's about some organizations like SpaceX, NASA, Tesla, blah, blah, blah. So let me just run this documents. Now, this will be coming from your document. Now you can have PDFs, docx, Markdown, so on and so forth. You'll be using some loaders based on if you are using LangChain or Llama Index, whatever. So basically this becomes your documents. Now I'm using text embedding 3 small model just for the demo purpose to create the embeddings for these documents, basically the vectors. And that's what I'm doing here. Oh, excuse me. Let me run this. I don't know if I ran it. Hopefully I ran it, and now I'm creating the docs embeddings. And basically we need again a function for this because we want to find out the similar, the similar vectors or the chunks, whatever you call it, over here. And that's what we are doing. You can find out the code here, the distance based algorithm that we have that will find out the similarity vectors. and then we just use this. So let me just run this here. And now we have a RAG model. So if you look at here, we have a class called RAG model. Earlier we had a class called, what was that class? We have a translation something in earlier. Now we have a RAG model class. I'm again using weave.model and passing GPT-4o. And what we'll also do with GPT-4o mini and see what happens. So if you look at here, the model name is string GPT-4o by default. And then we have a predict function passing a very simple prompt like please answer the questions only from the context, not from outside the context, and pretty much similar thing, keeping temperature zero. Don't want to be really creative and bringing up the randomness within it. So let me just run this. I don't know if I ran the above thing. Okay, cool. And now I'm asking a question, what is NASA? And this is my GPT-4o model that you can see it over here. You can again change the model name, of course, and the idea is to basically compare the different models and how it's different. And we're gonna look at that. Let me just open it here. Now, if you open this, you can find out we have something called rag model.predict, that the trace. Earlier we using translation model.translations. You can see it over here. Now we have rag model.predict, and you can find it out. So let me just run this. You have two things here. If you look at the rag model.predict, let me just come here, how much time it took. So now it gives you the answer. It also gives you the context. NASA is the United States government agency responsible for blah blah blah. This is the context are nothing but the retriever that we have retrieved, and this is the answer here, and this becomes your question, right? Now pretty much code thing that you have the same thing, that because we are using weave.op, that basically records all the functions that we have. We don't have feedback, and this remains the same, right? Now let me just go to, you can find out all operations over here. You can see all the operations, their different versions, blah, blah, blah. In the traces, you can find out rag model.predict. That's what we just looked at. Let me show you data sets. We don't have any data set yet. We're going to create something here. I'm going to show you models. You can find out all the model classes. This happens when you define the weave.model. Okay. Now rag model version not, version 0, whatever you call it, the use of it, how you can use it, calls, blah blah blah, consuming call. If you click on this, it directs you there, ragmodel.predict. Okay, now evaluations we don't have yet. We're going to create an evaluations pretty soon, because the idea is to evaluate two different models for a rag chatbot or a rag pipeline, right? Let's go back to traces here. Let's go back to code. Now here I have bunch of questions. You can see I have 6 questions. Who founded SpaceX? This is related to the documents that we have over here. You can see the documents. So let me just come here, and I'm just going to run this. So let me just run it. And now I'm just again using that same thing here. So let me just run. And now we are using weave.evaluation. So earlier we have weave.op, weave.model, and now weave.evaluation are three different, if you talk about the life cycle, if you want to really go end to end using weave. So you have to use op that can record everything. Then we have model that will record the model thing through a, inheritance class or something. And then we have an evaluation that basically evaluates that. So let me just run it over here. I don't know, I ran it, and now I'm running it. So you can see we're using the GPT-4o model, and then we'll change the model in the next code, which is GPT-4o mini, for this given set of questions that we have. So let me just come down. Takes a bit of time. You can see evaluated 1 of 6 examples, evaluated 2 of 6 examples, and evaluated n of n examples. And it gives you, context precision score and model latency. By the way, if you don't know, underneath it uses something called RAGAS. So RAGAS is again an open source tool that you can use to evaluate your RAG pipeline. Pretty famous in the ecosystem. So you can have a look at RAGAS. I also have a video on RAGAS as well. So RAGAS is basically, qualitative measures how good the quality of an output is. That's what it is. Now, that's what we are doing here. Now what we're gonna do, okay, let me open this thingy here. Okay, and the next thing we're gonna use GPT-4o mini. So let's run GPT-4o mini, and now here we use GPT-4o. So now we're using two different model, guys. That's what is important. Now let's come back here first. Okay, you can see this is an evaluation.evaluate, model latency, context, blah blah blah. Here you have context precision score dot verdict, model latency, average total tokens. You can find out, all the metrics over here, how much time it took to generating the answer, the total tokens it consumed, all the questions that we have, who founded SpaceX. Example 1 of 6, by the way. If you go next, it will go to the next question. Okay, like just over here. Who founded SpaceX? It says Elon Musk founded SpaceX. SpaceX is a private aerospace manufacturer, blah, blah, blah. And here you get the metrics, context precision score 100%, model latency 1 second per this, and total tokens that it consumed on average 87. You can go for the next question over here and find it out as well. If you go to next, you can find it out over as well. So all the 6 questions that we have. Now this is for this model, guys. I am more interested in the comparison part of it. So if you just come here, let's open this as well. And this is for GPT-4o mini. And this is for GPT-4o mini. And for GPT-4o mini, let's come down. You can see the total tokens. I don't know. I mean, I'm to see here total tokens. Yeah, a bit higher. Excuse me, I changed it. Okay, probably it's refreshing. Yeah, it makes sense real time. 1369 and blah blah blah. You can see average. There is a bit different, of course. Now we have these two thingy, right? Now what I'm gonna do is go into evaluations. So if you go into evaluations, this might take a bit of time. I've seen the lag here, when you go into evaluations, it takes a bit of time for the evaluations to show. You can see it's showing only one evaluation. It should show me two so I can compare because I ran it twice. I don't know. I mean, let me just come here, model. Yeah, evaluation, zero RAG model. Let me see if you open this here. What has it used? RAG model. Okay, V1. Okay, that's good. Okay. Okay, we'll go to models, RAG model V1, come to operations, and you can find out all operations. Cool. Evaluation still not one. Okay, let me run this. I don't know if I ran it. Okay, so I'm gonna run it. The idea is to compare. Once you compare, it gives you a comparison chart. Okay, I did that. To probably we have to refresh. Okay, now cool. Surprising. Okay, but why do I see if I open this evaluation? That's good. Okay, if you go to datasets here, it should show you the datasets, all these questions that we created. So dataset is fine. If I go to evaluations, okay, and I'm gonna do is I'm gonna run this again and see one thing. Let's see. Evaluated one of 6 examples, evaluated 6, mean, and okay, let me open this. And what does it show? Okay. So the only thing is one should be V0 and V1. So if you come to evaluations here, I really don't know why there's some lag of course here that I can see. And now it makes sense. Now what I'm going to do, I'm going to compare between these two. That's what I'm going to compare. Yes. So you have to probably refresh and stuff. Now if you see here, there's a difference. So there's a difference between, so what we are doing, we are taking RAG model V1, version 1 and V0, which is two different models. Now if you look at here, we have model latency. There's a difference between the model latencies and the total tokens. Context precision score, because this is a fairly simple context. The retrievals are not that difficult. It's not a complex document or a data set, very simple like Python list where we are storing and creating vectors. So this is probably you have to check it on your use case and data set that you have, that how it's behaving, the different models. And you can have two open source LLMs as well that you can use through Olama or something to do that. Okay. Now you can see the model here. It's GPT-4o mini. It's GPT-4. So the two different models. And you can find out this is simple. This is a bit. So GPT-4o mini is taking a bit more time when it comes to model latency, and the tokens it consumes more as well. You can see it over here. And then we have a bit of fancy graphs and charts, and then we have some comparisons over here, that we can find it out. Something is definitely there. Let me see. This is pretty same. The context remains same. Okay, the answer is pretty same for this. If I make next, yeah, this is something responsible for space exploration and research. So it has added something called research over here, and this remains same. Okay. Now if you go to next question, it only says Tesla, which company is focused on accelerating the transition to sustainable energy, but this has basically given a very good statement kind of an answer here. So this is pretty good. And this is how you can evaluate, guys. Very important, I believe. You look at here, Blue Origin, only like giving a like a simple answer. Prompt also plays a role, so you can improve the prompt. But here it says Blue Origin aims to make space travel more affordable and accessible. If you go next year, it's saying Boeing, but here it basically it's more the verbatim is very good. It's really verbose and descriptive, even for these kind of questions. So if you want a short answer, you can look at probably GPT-4o for this given data. If you want a bit descriptive answer, you can look at GPT-4o Mini. Okay, this is what it is, guys. Pretty standard kind of a dashboard that you get here. Very good for evaluating and baselining. I'll say for baselining, this is pretty good. If you look at the models, you can go and look at all the models, versions, data sets. You can put up your own data sets over here. Traces, you can find out all the traces that you can see it over here. Well, this is fantastic. Operations, all the operations are here. Vanderbilt weights and bias is pretty famous. We have been using it till like last 10 years. We've been using, for earlier machine learning projects, deep learning, training, neural networks, and so on and so forth. Now we have Gen AI. It's a bit hyped up. Yeah, but weights and biases have again we really improved. They have we've now like these are very latest features. Earlier, like few years back, these were not there. So just wanted to show you. You can also invite your teammates. You can do a lot of things over here. You can go to settings. It's like I'm using a free account based on your uses. You can again take a premium one, but pretty good for smaller proof of concepts and MVP. Okay, that's all for this video, guys. Wanted to create a video on how you can baseline different racks, different models and building a rack pipeline and so on and so forth. Notebook will be available on GitHub repository. I'll give the link in description. If you like the content, please hit the like icon. If you haven't subscribed the channel yet, please do subscribe the channel, guys. That motivates me to create more such videos. You can also join our Discord community. I'll give the link in description. It's really growing. We help each other. There are a lot of opportunities, job, internships, etc. Right? If you have any question, thoughts, feedback, let me know in the comment box. You can also reach out to me through my social media channels. That's all for this video, guys. Thank you so much for watching. See you in the next one.